The title of this chapter section is Frequency Distributions, Histograms, and Related Topics. When we have a large set of quantitative data, it's useful to organize into smaller intervals or classes and count how many data values fall into each class. A frequency table does just that. A frequency table partitions data into classes or intervals and shows how many data values are in each class. The classes or data values are constructed so that each value falls exactly into one class. Here's an example. What we're going to do is we're going to construct a frequency distribution or frequency table together. A task force to encourage carpooling did a study of one-way commuting distances of workers in the downtown Dallas area. A random sample of 60 of these workers was taken. The commuting distances of the workers in the sample are given in Table 2-1. Make a frequency table for this data. So here is the data that we are given. So to make our frequency table, what we're going to do is first we want to decide how many classes we want. Usually you're going to want between 5 to 15 and a multiple of your total data. So our total data is 60. We have 60 random samples. So if we're going to pick a number between 5 and 15, I think we'd want to choose 6 because then we're going to have a nice spread to show our data. If we use 10, the data probably would be crunched in a bit more and it would be hard to read and really assess it. Next, we want to find the class width of our data. So to find the class width, what we're going to take is we're going to take our largest data value and subtract our smallest data value. And we're going to divide it by our desired number of classes. Remember that we wanted 6. So if we take 47, subtract 1, and then we're going to divide it by 6, we get 7.7. And you always want to make sure that you increase it to the highest whole number. So therefore, we're going to round up to 8. Next, we're going to determine the data range for each class. So we have the lower class limit and we have the upper class limit. So the lower class limit is the lowest data value that can fit in a class, while the upper class limit is, you guessed it, the highest data value that can fit in a class. The class width is difference between the lower class limit of one class and the lower class limit of the next class. Basically, our lowest limit is 1. So to find the range, what we're going to do is we're going to add our lowest limit 1 to our class width, which is 8. So 1 plus 8 is 9, so we're going to use 9. And we're going to do this for all of our lower class limits, and then again for our upper class limits. I'll show you on the chart. But next, we're going to tally our data. So essentially, we're going to go through our whole set of data, and we're going to count each value that falls into each particular category. For example, you're going to look at the data and you're going to see where it fits. So if our first data value is 13, I'm going to make a line or tally mark in the 9 through 16 class because it would fit between those or in those. So we're going to do this for all of our data. And then the frequency is essentially how many tally marks you made. To find the midpoint of our data, we take the lower class limit and add it to the upper class limit and divide it by 2. To find the class boundaries, what we're going to do is to find our upper class boundaries, we're going to add 0.5 to the upper class limit. And to find the lower class boundaries, we're going to subtract 0.5 from the lower class limit. So if we look at our chart, notice our tallies. If we count that first row, there's 14. Remember to find the midpoint, we add the 2 together. So we have 1 plus 8, which is 9, divided by 2 is 4.5, and that's our class midpoint. And then remember to find our class boundaries, we're going to subtract 0.5 from the lower one, so 1 minus 0.5 is 0.5, and add 0.5 to the higher. So 8 plus 0.5 is 8.5. And notice how this applies to each row. Basic frequency tables are going to show how many data values fall into each class. It's also useful to know the relative frequency of a class. The relative frequency of a class is the proportion of all data values that fall into that class. To find the relative frequency of a particular class, you divide the class frequency by the total of all frequency in the sample size. Look at this table here. So we have our class limits and our frequency from the table on the other slide. So remember, we have 60 pieces of data. So remember that our first row, we found 14 pieces of data that fell between 1 and 8. So we take our 14 and we divide it by the total amount we have, and we got 23%. We then do that for each frequency value. So now we're going to talk about the distribution of shapes. So first we have our uniform or rectangular. These essentially look like little soldiers standing in line. They're all about the same shape, they're symmetric, and the bars are all about the same height. Some of them can be a little bit shorter and a little bit taller, but if you squint really hard, they're all going to be about the same height. Then we have mound shape or symmetric. Usually these are called symmetric, and you kind of want to think that if you fold it in half, it's going to be the same on both sides. Then we have skewed left or skewed right. So this is where our data kind of falls down, almost like you're sliding down a slide, or you're pulling the data to the left or the right. So you want to know for skewed left, the data is going to be pulling down to the left, or like if you were to ride a slide, you'd be sliding down to the left. And same for skewed right. If you were to climb up one of these and slide down it, if you slid to the right, the data would be skewed to the right. Then we have bimodal. Pretty much with bimodal, you want to look for two distinct humps in your graph. You kind of want to think if you were to take a blanket and throw it over your graph, there'd be two bumps. And then lastly, outliers. Outliers are pretty noticeable when looking at graphs because there's a big noticeable space between pieces of data. The cumulative frequency for a class is the sum of the frequencies for the class and all previous classes. So for example, let's look at our first row again. We have 14. All right, that's our cumulative frequency. However, for our second row, with the class limits of 9 through 16, we have 35. That's because we took our first row and added it to our second. And you keep doing that to get all the cumulative frequencies. An ogive is a graph that displays cumulative frequencies. Using the previous chart, we're going to calculate the cumulative relative frequency. And there's our graph.